All right, well, welcome. I'm JJ. Let's tackle an example problem. So this time we have a 450 Newton force, and we're trying to figure out the following things. What's the x component, y component, and z component? So we have a force going off in 3 dimensions here, not just in 2 dimensions. What's our force as a Cartesian vector? Then we'll figure out what is alpha. We don't know it to start out. We know our beta and gamma coordinate direction angles. And then we're going to figure out what's our unit vector that points in the same direction as this force vector. So let's just jump in and go for it. So our alpha, beta, gamma angles, by definition, are always going to measure from the force. For alpha, it always goes to the positive x-axis. For beta, from the force to the positive y. For gamma, from the force to the positive z-axis. That's always true for us. Well, also, anytime that we label x, y, and z axes, we're going to assume that we're labeling the positive ends of our axes in here. So this is to the positive, positive, and positive. But for any one of these, we can say that my force in any direction is the total force times the cosine of the angle that goes to that axis. So for example, Fy. I could say that my force in the y direction is my total force, 450, times the cosine of beta, because beta goes from the force to the y-axis. Cosine of 40. This will get me one of my answers. I should get from this that Fy is 345 newtons. And we can always, as we come in and do this, cosine will always get us the piece that we're looking for on that. Similarly, I can get that my Fz, that force in the z direction, is my total force, 450, times the cosine of gamma, which I know gamma is 70 degrees. Cosine 70. Or my Fz ends up being 153.9 newtons. 153.9 newtons. Which is the second answer for us. I don't know alpha, so I can't take the same approach to get Fx, even though I could say Fx is 450 cosine alpha. Without Fx being known, or without alpha being known, I can't use that yet. So what else could I do to get Fx? Well, remember, I have y and z components, and I know my total force. I can come in and use a 3D Pythagorean theorem and say that my total force is the square root of Fx squared plus Fy squared plus Fz squared. I have Fy and Fz. I'm going to come in here and say I also know F is 450. Really, Fx is my only unknown in here. This is the same thing as my total force, 450, equals the square root of Fx squared. That's my unknown I'll solve for. Plus Fy squared, but I know Fy, 345 plus 345 squared. Plus Fz squared, and I know that, plus 153.9 squared. Fx is my only unknown here. I should be able to solve for that. I'll get that Fx is 245 newtons. Technically, just so that we acknowledge it, this could be positive or negative 245. I'm just making the assumption I'm taking the positive root. But from there, we can keep going with that. We can say, if I know Fx, well, that actually takes care of all of part A for us. I have Fx, Fy, Fz. I also now have enough that I can get F as a Cartesian vector. My force as a Cartesian vector should be my x component. I'll pull the newtons out, but 245 I plus my y component in the j direction plus 345 j plus my z component, 153.9 k newtons. Which gets us, really we're just pulling those x, y, and z components into one statement and getting I, j, and k tacked on to establish direction with that. But that is the second part. Really, if we have X, Y, and Z components, that part B should be really easy for us. We can also figure out what is alpha at this point. We used before Fy was F cosine, beta, Fz was F cosine, gamma. Really, I can do that same thing for Fx. Fx is my force times the cosine of alpha. But again, as I come in and do this, I know Fx, I found that just a minute ago, is 245. I know F is 450. Alpha is my only unknown in there. I should be able to solve for that. With only 2 of my coordinate direction angles known, I should be able to get to the third one every single time. My Fx, 245, is equal to my total force, 450, times the cosine of alpha. Cosine alpha. I'm dividing through by 450, taking the inverse cosine. I'm going to get that this will lead us to alpha is 57.1 degrees. Again, if I come in and I had assumed Fx was the negative root in here, I would be getting a different angle out here. But logically, we should be able to follow through. What did we assume? What angle do we get out here? But that is my second part for this. Finally, I'm asked for my unit vector. I can get my unit vector by just saying that my unit vector in any direction, so in the direction of my force, should be equal to, let's just cosine alpha in the I direction, plus cosine beta in the J direction, plus cosine gamma in our K direction. So let's go ahead and tackle this. This is the same thing as filling in our values. Cosine of 57.1 I plus the cosine of beta 40 J plus the cosine of gamma 70 plus cosine 70 K. Or my unit vector, UF, should get me to 0.544 I. Plus, in the J direction, we'll get plus 0.766 J. And then finally, cosine 70 in our K is going to get me to plus 0.342 K, which would be my final answer for everything. Again, the key thing on this, we can use our alpha, beta, gamma angles. We really only need 2 of them if we know our total force to get our entire problem worked out. But if this is helpful for you, hit that like and subscribe. Stick around. Let's get an A with JJ.